Hi, welcome back to Alien Space Education. My name's Andy, your host. I'd like to apologise that this is a little bit late. I've had a lot of personal issues going on and I'm trying to get back on top of these. I will keep doing them and there will be more coming out soon. So please keep watching, please keep listening, please keep sharing, liking. And remember, if you have any comments or anything like that, please put them below. I will happily get to them and I will respond as soon as I can. Okay, so we're going to today focus on the astronomical beautiful planet Jupiter. With its immense size, powerful storms, complex systems of moons, Jupiter is a planet truly lives up to its name as the king of planets. As we explore this massive gas giant, its intriguing features, its fascinating moons, what makes it a vital piece of our cosmic puzzle, where it fits in our solar system, why is it so important, and why is it so great? So, getting straight into it. Jupiter, the basics. Jupiter is the fifth planet from the Sun. It's the largest planet in our solar system. It is so massive, it could contain all the other planets combined and still have room to spare. Jupiter has a diameter of about 139,820 kilometers, or 86,881 miles, which makes it 11 times wider than Earth. Its immense size is measured. Immense size means it has a volume large enough to fit more than 1,300 Earths inside it. That is huge! One of the most striking features of Jupiter is its composition. Unlike terrestrial planets like Earth, Venus, Mars, and Mercury, Jupiter is a gas giant. This means it's composed mostly of hydrogen and helium, with traces of other gas like methane, ammonia, and water vapor. Its atmosphere is incredibly thick and extends deep into the planet. So you think of Earth, its clouds are very, very thin. They're up in the sky, very thin. But as you get closer to Earth, it gets thicker because we're more the gas, and that's how we can breathe it. As you get closer and closer and closer, you get Earth. Now imagine that gas, the atmosphere we have, is miles thick before you get down to the core in the middle, all gas. So it's extremely dense, extremely gassy. Jupiter's day is relatively short. It lasts about 9.9 hours, so it spins really, really quickly. Despite its rapid rotation, the planet's day is not uniform. Jupiter's fast spin causes its atmosphere to display noticeable bands and belts, clouds creating stunning, complex cloud patterns we see in images from space probes. So all those rings and everything like that are all because it's spinning super, super fast. And you can do an experiment with this. If you draw dots on a bit of paper, put a pencil through it, and you spin it, how do those dots appear? They look like they're circling, don't they? And that's what's happening, very similar to what's happening in the atmosphere of Jupiter. Jupiter's year is equivalent to about 12 the gas giant, 4,333 Earth days to complete one orbit around the Sun. Its distance from the Sun of about 787 kilometers, or 787 million kilometers, or 484 million miles. Jupiter receives only about 4% of the solar energy that Earth does, resulting in a much colder environment. Now, the gases on top that are really, really high up, remember, it's very thick, very wide. It's very, very cold. So these gas is swirling so fast, it's keeping the gas in a gas state. They're not letting it freeze, even though it only gets 4% of sunlight. So the further down it goes, it's getting hotter and hotter and hotter in the middle, because it's so thick. So the atmosphere and the weather. Jupiter's atmosphere is one of the most dynamic and complex in our solar system. It's composed primarily of hydrogen, about 90%, and 10% helium, with traces amounts of methane, ammonia, and water vapor. The atmosphere is layered with different bands of clouds, each with its own characteristics. Now, just because the bands are different colour doesn't mean it doesn't have a bit different mix of gases. It could be there's something else in there, the trace elements, making it look like a different colour. Remember, it's also spinning super, super fast. So what happens when colours mix together? They blend and they change colour. This is also happening as well. So there's a lot of different things going on with these clouds. The most famous feature on Jupiter atmosphere is known as the Great Red Spot. An enormous storm has been raging 400 years, possibly much longer. The Great Red Spot is a giant anticyclone, a high-pressure system. It's about 1.3 times the diameter of Earth. The storm is reddish colour and is subject to scientific debate, with theories ranging from chemical composition of the storm and its interactions of sunlight with the planet's atmospheric chemicals. The sunlight, even though it only sees 4% of the sunlight intensity we receive, we know that gases can change with sunlight hitting them, and the Great Red Spot could be having an effect there. We also know the Great Red Spot is also shrinking in size. Used to be as wide as 3 Earths. It's now down to smaller, 2, maybe about 1.3 times the diameter. So it is getting smaller. So maybe one day it will disappear, or maybe it will expand again. We don't know. It's a weather pattern, and if you live in the UK, you know UK weather reports are very difficult to predict. It could say it's going to be hot and it could rain. The same is with the Great Red Spot. If we're looking at it as a weather system, it is very unpredictable. Jupiter also features bands of clouds known as zones and or belts. These bands results from the planet's rapid rotation, which creates strong jet streams that drive movement of the clouds. The lighter colour of the zone are the areas rising, cooler air, while the darker belts and regions are descending, warmer air. These bands are aligned parallel to Jupiter's equator and contribute to the planet's striking striped. So just like the British weather, cold air rises. Let's get this right. Yeah. The cold air rises, the warm air sinks. So the lighter it is, the colder it is, the darker it is, the more it's sinking, the more you're seeing deeper into the Jupiter. And that's what it is. And that is always changing and rotating, just very similar to the cycle of clouds and rain on Earth. It's doing a very similar pattern, but it's gas clouds doing this. So the gas clouds go down, and then as they heat up, they turn into a finer gas, and then they rise up, just as the heat pushes things up, and it gets thin, it gets colder as it rises up, so it turns lighter, comes back across, and eventually, just like rain, it pours back down, and then it gets thicker and deeper into the planet, and therefore it changes colour. That's the easiest way I can explain it. There's a little bit more technicality to it, and I'll try and do a deeper video on this later, podcast on this later on. Additional to Jupiter's ring system of rings and structures, though they faint compare, Jupiter has structures. Although they are faint compared to Saturn's magnificent bright rings, these rings consist of small particles of dust and ice and are thought to be relatively young, possibly formed by debris from left by meteorite impacts on Jupiter's moons. Now, what it's saying is Jupiter does have rings. Yes, they are. They're dark, so they're made of rock, while Saturn's rings are made of ice. So, because Saturn's rings are ice, they shine off the light. Jupiter's rings are dark. Rock is dark, so therefore it doesn't shine as much light, so they're much harder to see. Now, we don't know how these rings got there, when they first appeared, when we first discovered them. And we don't know how long they're going to last. And some of this debris, as Jupiter, does create more moons. It does collect and create moons, or it could be a moon that's broken apart and shattered and left a trail of dust. So we're not sure what they are, but we do know they're there, and we can see them in certain light if it's really, really depending on how it all looks. So there is the opposite. We can see them, but very rarely. If you have a telescope, you have to get it precisely right. If you look it up, I will be continuing this podcast on the stargazing, and I'll give you hints and tips on how to see them. So moving on, Jupiter's Galilean satellites. Jupiter is not only the largest planet in the solar system, it has a most impressive array of moons. Over 90 have been discovered so far, possibly more. Among these, the 4 largest, known as Galileans, are particularly noteworthy. Discovered by Galileo in 1610. So you're talking over 400 years ago. Someone with a telescope saw Jupiter and saw it had some moons. These moons are some of the largest objects in the solar system each offer a unique feature of scientific interest. So we're going to cover these 4 moons. So let's start with Io. Io, the innermost of the Galilean moons. Io is the most geological active body in the solar system, with hundreds of active volcanoes and extensive lava plains. The moon's surface is constantly reshaped by volcanic eruptions. It is covered by sulfur compounds, giving it a colourful orb with yellow, reds and browns. The intense volcanic activity on Io is driven by tidal forces from Jupiter's gravity, which causes internal heat and friction. So Jupiter is playing a massive role on Io, changing it, forcing it to twist and turn, the tectonic plates to change, and these volcanoes constantly erupt. So highly unpredictable, highly dangerous place. Next is Europa. Europa's moon is covered by smooth, icy surface, and is believed to cover an ocean of liquid water beneath. Europa's surface is crisscrossed with networks of cracks and ridges, suggesting that the icy crust is floating on a subsurface ocean. This ocean may be in contact with Europa's rocky mantle, creating conditions that could potentially support life. Europa is a major target of future explorations, with missions like Europa Clipper planned to investigate the icy shell and subsurface ocean. So you think when you have a glass of water, there's water on top, or you look at Earth, you have water underneath and you have ice on top. That ice is similar to what Europa has, and underneath, even in the Antarctic, where we've drilled through miles of ice and looked underneath, Ganymede, the largest moon in the solar system, is even larger than Mercury. Ganymede has a magnetic field, which is unique among moons of Jupiter. The surface that shows evidence both old and heavily cratered regions and younger, less cratered areas. This suggests a history of geologic activity, possibly involving a tectonic process. Just like Earth, we have tectonic plates. Ganymede has that as well. Plus it has the magnetic field. So it's generating magnetic field. So does it have solar auroras? We don't know. We're all looking at it, and it's a moon. It's very large, very far away, but we are looking at it, we are monitoring it, and there could be more to learn. It may also have the possibility of life. Just like Mars, millions of years ago, billions of years ago, could have had life. Ganymede could have too. And considering it's larger than Mercury, it could be that it came from somewhere else and got caught in Jupiter's orbit. So we don't actually know much about Ganymede, but there is strong evidence that it's a very active planet and things are always changing there. Who knows what's on there? Finally is Callisto. The most distant of the Galilean moons is heavily cratered surface, making it one of the oldest surfaces in the solar system. Callisto's surface is covered in ice and rock, and it may have a subsurface ocean as well. It lacks significant geological activity, makes it a key target for understanding the early history of the solar system. So just because it's a rock and doesn't look like anything going on, it's been impacted with lots of things, it could give us clues about early life within the solar system, early things going on. And it's a very good point to look at to understand the future. We have to look at the past and see how things have changed, see if there's changes, and see if those cycles are happening again. One thing all these planets, all these moons have said is they're heavily cratered. They get impacts. This is because Jupiter does have those rings, and it's always collecting asteroids, meteorites that are flying around, and they do get heavily impacted. So they will always be heavily impacted. Whether they will get more and more and more, which is very likely, whether we see those impacts is a different thing, because we have to be looking at the right spot at the right time to see them. As cameras and telescopes get better, we will be able to see this hopefully in the future, and hopefully we can do a video on that as well. Now, they're the 4 largest moons, the Galilean moons, which we'll remember was over 400 years ago, and we were seen by a very simple telescope. So if you have a telescope and you see Jupiter, there's a very strong possibility you'll see these 4 moons as well. Take note of them. They're important and they're very pretty. Beyond the Galilean moons, Jupiter has smaller moons with irregular orbits. These moons are often captured asteroids or comets, and highly erratical orbits, suggesting a violent history of collision and gravitational interactions, which goes back to why Jupiter has rings, because they're dark. These moons, orbits, comets, and meteorites could be catching, could be pulled apart to give it dark rather than light rings. And also, if it's catching meteorites and comets, some of this debris that it breaks up could be impacting on the moons, the Galilean moons we just talked about. Jupiter's magnetic fields and radiation belts. Jupiter has a magnetic field. Is so strong that planets in the solar system, that any planet stronger than any planets in the solar system, about 14 times stronger than the Earth's magnetic field. That's powerful. This magnetic field extends millions of kilometers in space and has a profound impact on Jupiter's environment and its moons. Remember, this magnetic field will impact the moons because it stretches miles. The magnetic field is generated by motion of metallic hydrogen inside Jupiter. This motion creates a dynamo effect, which produces vast magnetic field that traps charged particles. These particles form the planet's radiation belts, which are much more intense than Earth's. Jupiter's radiation belts pose a significant hazard to spacecraft and could affect potential for human exploration. Now, radiation, as we know, can be used in hospitals like doses to help us look inside our bodies. But massive amount of radiation, such as nuclear power stations and things like that, can cause really bad things for Earth, for humans, as we're seeing by the Chernobyl disaster. It's going to take years and years and years before we can actually go near that again. Now, in space, we don't have the protection from our magnetic field, from the sun's radiation, because we get solar auroras and things like that. Radiation is dispersed and we are protected. When we're going in a spacecraft and we go past something like Jupiter, it's producing radiation, it's getting spilled out. We have no protection and no way to protect any spacecraft that go past it yet. We are working on it. We will figure it out. Maybe you can come up with some ideas to help us. It's a good idea, good thing to look at. So consider those future space missions. When we do go to space missions, and we do use Jupiter's orbit to slingshot missions further in space, we have to stay so far away from Jupiter that the radiation doesn't damage the equipment. How are we going to do it so it doesn't damage our spacecrafts if we put them in interplanetary species? How are we going to do it so it protects us? How safe, how close can we go if it's a mad mission? A lot of questions. One of the most fascinating features associated with Jupiter's magnetic fields are the auroras. Jupiter's auroras are the brightest in the solar system, are created by interactions of the planet's magnetic field with the solar winds, charged particles from the sun, as well as particles ejected from Jupiter's volcanic moon Io, collide with Jupiter's atmosphere, creating stunning auroras near the planet poles. Just like Earth, it has its own planetary auroras, but we also bring in what's coming from Io, so it's getting charged from both sides, the planet and its moons. Ours doesn't. So these are really different colours, really different effects, and have a really profound and beautiful look. You also need a lot more powerful telescope to see that than what it probably has. But if you ask around, I will put some links onto my website, Space for All Education, images of these auroras, so you can actually have a look at how different they are from the Earth's auroras. The magnetic field also influences the environment of Jupiter's moons. For instance, interactions between Jupiter's magnetic field and the volcanic activity creates large plasma torus of plasma around the planet. These plasma interactions with Europa, Ganymede, and Callisto influence their space environment and potentially their subsurface oceans. So there is an interaction between these four moons, between Jupiter and that, because they are so close. And these auroras, the magnetic field does influence to keep them close, but not push them away, just like Earth's moon. But there is something going on between there that we don't fully understand, and these plasma is going to have an impact on them. How does that plasma have an impact? We're not sure. We're looking at it. Exploration of Jupiter, past, present, and the future. Yes, we are looking at all of it. Jupiter has been a key target for exploration since the early days of space missions. Study of Jupiter has provided us with valuable insight into the nature of gas giants and the dynamics of the planetary system. First spacecraft to visit Jupiter was Pioneer 10, which flew by the planet in 1973. Close-up images of Jupiter, followed by Pioneer 11 in 1974, which also flew by Jupiter and held helped to refine our understanding of the planet's atmosphere and magnetic field. The next missions were Voyager 1 and Voyager 2, which conducted flybys of Jupiter in 1979. These spacecraft provided detailed images of Jupiter rings and moons and made significant discoveries, including the volcanic activity on and the icy surface of Europa. In 1995, the Galileo spacecraft arrived at Jupiter and spent 8 years studying the planets and its moons. Galileo provided a wealth of data about Jupiter's atmosphere, magnetic field, moons, and detailed observation of Io's volcanoes and evidence of subsurface ocean on Europa. The most recent mission to Jupiter is Juno spacecraft, which entered orbit with Jupiter in 2016. Juno is designed to study the planet's atmosphere, magnetic field, gravity field in order to better understand the formation and evolution. The spacecraft has provided high-resolution images of Jupiter's poles and has helped us reveal the intricate structures of the planets and cloud belts. So you can see, from 1974 to 2016, and we're still studying it now, we are still learning exactly how all this works together. And one of the things that we are learning is the previous mission, Galileo spacecraft in 1995, because we couldn't do much with the Galileo spacecraft. In order to understand Jupiter better, we crashed it into the planet to find out exactly more about its atmosphere and things like that. So we're using the spacecraft to their full potential to learn as much as we can. And we're going to keep learning more and more and more. We are still taking our first baby steps to look at this under a microscope. But because it's so big, we can only look at it small pieces at a time. So there's a lot to learn, a lot to do. There are more future missions coming up. There are several exciting missions planned for Jupiter and its moons. Europa Clipper Mission Moon 1, set to launch in 2020, which will conduct a detailed reconnaissance of Europa's icy shell and subsurface ocean. It will go into the water on another planet and transmit the data back. Will it discover life? I don't know. Additionally, the JUICE, Jupiter's Icy Moon Explorer mission, led by European Space Agency, this will study Jupiter's atmosphere, magnetic sphere, and its moons, and focus on Ganymede, Callisto, and Europa. Different spacecrafts are looking at different things, and depends on the orbits, depends on which ones it can look at. These missions will continue to expand our knowledge of Jupiter and its complex system, providing insight into the formation of the gas giant and potentially the habitability in the outer solar system. So we're not just looking at living at Mars, it's can we live further than that on one of the moons of Jupiter? Is it possible? Would Jupiter allow us to pass safely, human transportation pass safely around it? Or do we have to avoid Jupiter altogether and avoid the asteroid belt? There are things that we have to learn, and we are starting that process. We still have a lot to learn. And I'm hoping that you might inspire the listeners who are taking this journey with us, are going to help us understand more. You're going to be inspired enough to say, I want to study that, because we need you to. You're going to come up with questions that we haven't thought of. You can come up with ideas on how we can do things better. Please keep listening. Please keep sharing. In conclusion, our journey through the king of our solar system. It's clear Jupiter is a planet of immense complexity and grandeur, from its colossal size to its powerful storms, to its fascinating moons and intricate magnetic field. Jupiter continues to be a source of wonder and scientific intrigue. The exploration of Jupiter and its moons not only enhances our understanding of our solar system, but also provides valuable insight into the formation and evolution of planetary systems. As we look forward to future missions and discoveries, the gas giant remains a key piece of the cosmic puzzle. The more we learn, the better we understand. We are still making a giant puzzle, and we're only in the corners. We have a lot to learn, and Jupiter does hold significant keys to help us get there. Thank you for joining me in this episode. I hope you've enjoyed it, enjoyed our exploration of Jupiter. Please subscribe, rate, leave a review. There is much more to learn, and the more you guys help me by liking, subscribing, by sharing, whatever you do, please keep it going. Keep looking to the stars, and I look forward to you. I hope you enjoy our next episode, which will be on Saturn. That's where we're going next. Keep exploring. Thank you.